Yeah, I've got to complete the square a couple times, right? I have a green one, dude. All right. So here for the x's, what would I have to add to both sides?
16.
Yeah, half of 8 is 4, squared is 16. And for the y's,
9.
yeah, 9, right? Half of negative 6 is negative 3, squared is 9. So this will be x, half of 8 was 4. Is that cool? I mean, and this will be plus y, half of negative 6 was negative 3. I can see why I made it 0 so that radius comes out nice. Maybe. What's the radius? 5. I love it. X squared plus y squared equals r squared, basically. And it's been shifted. So that's why the center is going to be somewhere else than 0, 0. Where's the center going to be? Negative 4? 3. Cool. So all I had to do, if I would have put a 2 here, like you guys said, now for the same reasoning, that would have been a what? Ellipse, because now that would have been a 2, that would have been a 1. It's not symmetric anymore. It's different depending on which direction you're looking at. It's differently reacting to the variables. Yeah.
What does the subtraction sign switch to?
It doesn't. I just put these out of order, so this is really y squared minus 6y, right?
Okay.
I like it. So the y squared piece is plus. The x squared piece is plus. So it's going to end up being a circle because they're also the same number. If this was a plus 3, like we just said, that would have been an ellipse because it's still x squared plus y squared, basically. And so how would I make it a hyperbola? Either put a minus there or a minus here, as long as they're different signs. The x and y's would be different signs. Okay, maybe. I mean, there's feels like there's a lot of parts to this, but there really isn't. I mean, it's actually almost too nice to believe how it just comes together. If I would have asked you, what do you think the equation of some freaky ass hyperbola would be, you go, oh my god, it's gonna be some weird shit. It's beautiful though. It tells you exactly how far to go, which direction. It's crazy. So I could do the same thing if I had, ooh, hello green, dude. Let's say 4x squared plus, yeah, sure, 8x minus y squared equals, oh, I have no idea, Jeff. Sure, 16. I like it. Why not? Well, let's see. Plus 1, plus 4. Yeah, let's make it 12. All right. See if I my way into a decent problem here. All right, what the hell do I do here? Well, first off, why is it what I said it is? Why is it in hyperbola?
So there's the negative in front of the y squared.
Good. The x squared piece is positive and the y squared piece is negative. It's going to be a hyperbola. I like it. And what do I do? Obviously, good. Take the 4 out so I can get the completing the square going. So what goes here? No.
1.
Yeah, half of 2 is 1. 1 squared is 1. Yeah, you don't look at that. You look at that's what's hardwired for completing the square. So if I add 1 here, I have to add 4. Because that's really what if I put a plus 1 here, I really just did a plus 4 to that side. So I better add 4 to the other side also. I can believe everybody's cool with that. I'm sure somewhere out there somebody, it's a freaking 1, but I'll do what you want. Silly math boy, whatever. Oh, wait, that's a 4x squared, that's an 8x, and that is a 4. There's just no escaping that is a 4. So this, how's this? This is 4 times x plus 1 squared minus y squared equals 16. Now, this is not a circle. This is not the right format yet. Divide by 16. You always want to make this side 1. Because the reason we do that is because then I can see, so in the x direction, how far would I go? In both directions, how far would I go from the center?
2.
Yeah, I go 2 out from the center, right? Here I go
8, 4.
4. It's always based on squaring, right? This is a squared, this is b squared. All right, no, I don't think we've done a hyperbola that was shifted. This is shifted just a little bit, right? Where's the center of this hyperbola?
-1.
Yes.
0.
All right, let's try to graph this thing. So the center. I was so hopeful about you. Is -1, 0. And I'm going to go out in the x direction. I'm going to go 2. And the y direction, I'm going to go out 4. And which axis is it going to sit on? Is it going to look like this or like that? This or that?
X-axis.
Yeah, x-axis. I like it because it's the positive one. It's the one that's allowed to have intersects. All right, so it's going to sit. It's going to look like this, basically. All right. Funny thing is, it is going to look like that, even though we'll see what I mean. So here's the center. The center is not really a point on the graph. It's just where I count from. So here's -1, 0. So from here, I'm going to count 2 in the x direction, right? Is that, you guys cool with that? You guys, so again, only a circle you don't make 1, because then that number would be the radius. There's no such thing as a radius for an ellipse or a hyperbola. It's more related to how far in each direction. That's why this is a better form for them. And then it's just these are the squares of how far you're supposed to go. It's almost too nice to believe if you let it be. So now from the center I go 2 out, bam, bam. Bam, bam. And of course in the y direction I go 4 up and down. 1, 2, 4. Is that a point on the graph?
No.
No. Okay, good. But they just give me my points so I can make my rectangle. I like it. If this would have been a plus here, I would basically be done. Do you guys see that? If this would have been a plus, this would have been an ellipse, and then I would have just went schwa-yuan. All right? But it's not, so is it you that's good? Maybe it's you that's good. Ooh, it's you that's good. Okay, sorry. So now I can make my little rectangle. And then I can make my little. So that's why the center is such an important point. Even though it's not a point in the graph, it controls everything. And now I just draw and kind of follow. Nice and fat dude there. Schwa. Stop making noises, Jeff. Jeez. All right. And if I wanted to find the focus, if I did want to find the focus, it would be c squared equals a squared plus, because it's always the opposite, plus a b squared. So c squared equals 16 plus 4. 20. So c equals square root of 20, which is in between 4 and 5, right? And you can reduce that and all that kind of crap if you really felt like it. Doesn't really matter. All right, so square root of 20, you can do it in the calculator. It comes out to be, we'll just say 4.6. Right. So it'll be, it's going to be way out here. So this is away. Is that many away from the center? So it'll be 1, 2, 3, 4. So do you see why it's fat? Do you understand what I mean by fat? It's fat, right? It's not skinny. It's fat because remember the focus. The closer it is, the more I curl around it. So the focus ends up being not right here. It ends up being over here somewhere. So that's why it allows it to be. It's not too concerned yet. It's like oh shit, and then again oh shit. Okay. Yes, sir.
And how can I find the vertices for that?
Vertices are just the points that they actually go through. So those would be the vertices.
Right.
These aren't really vertices because they're not really on the graph. The vertices of an ellipse are normally considered to be the points that are on the major axis, but also some books say it's all 4 points. Okay, maybe. So obviously I'm not going to need like a huge amount of detail from you here. I'm not even asking you to figure out the equations of these because who cares right now. Just want to get you a feel for the look of the equation and how it relates to the picture of it, to the graph of it. In pre-calculus, you're going to go a lot deeper, right? I think I've told you already, pre-calculus, I call it graphing hell because it takes you through all these ways of graphing things. And then when you get to calculus, the graphing is not an issue. It's the calculus. I like it. Anything else from homework stuff? Who was here? I think it was at the end of class. I always forget about this poor dude. Desmos.com. It's a really nice graphing utility. I think I showed you guys a little bit of it the other day, but it was towards the end of class. So if you don't have a TI calculator, even if you do, it's a really nice program, really nice graphing program. Okay.
I have to go to work tomorrow. I was wondering if sometime during class I could take the test for tomorrow or Wednesday. I have to go to work.
Well, shit. See me during the break, maybe. We have to figure it out. Yeah. That's all right. Okay. So there's no... Yes.
So, let's say if x was by itself, so the vertex for x will be only 1.
Let's say x is by itself. How do you mean?
Like, let's say y squared over 16 minus x squared equal 1. So the vertex would be 4 and
So what's underneath?
1.
Yeah. So it's nothing different.
Okay.
It's just weird because we don't write it to save time. But it acts the same way as if it was a 4, 9, or 16. It's the same thing. Yeah. So I'll go 4 out in the what direction?
The y.
Y, up and down, Y direction. And 1 out in the X direction. From the center, and the center here is
0, 0.
0, 0. Because it hasn't been shifted anywhere.
Okay.
I love it. Sweet. Okay. Yeah.
From 13.1 and the
13.1 number
72.
72? Oh, okay. The one that's got, find the center and radius of the circle, that one? All right, so 72, wait, 13, which one? 13.1, okay, so I'm in the right place. 72. Before you even write anything else, what shape is that going to probably be? Circle. So they already told you it was a circle, so it's not that. 12y plus 32 equals 0. Which variable needs our help?
Y.
And what thing is in the way? 32. I like it. So y's got pieces of itself scattered. We got to help it get its act together. 32's in the freaking way. So let me focus on this. Let me get the 32 over there. What's going to go here?
36.
Yeah, why 36? Because half of 12 is 6. Squared is 36. So put it plus 36 on both sides, thank God. Hopefully you understand. If I said x squared plus y squared equals negative something, no. Right? That can't happen unless I include complex numbers, and we don't. Trust me. Why don't you do that right now? So x squared plus, how do the y's work there? Yeah, y plus 6. I like it. Half of 12 is 6. Bam. So what's the center of the circle? Yep. 0, because that x wasn't shifted anywhere. And then it goes down 6. I like it. And the radius, of course, is 2. Yeah, so now you plot the center. You don't plot it, but you put a little circle. And then count from the circle, you count up, 2, over, 2, back, 2, down, 2. Yeah. I like it. I like it. Is that cool? Okay. Okay. Anything else from homework stuff? No. Okay. Couple things to finish out. Where were we? Here we go. Yeah, where did we end up? We still have a little bit to do, don't we? Let's figure out where we ended up. I think I did get all the way through. Holy shit! Remember that last thing we did? That was exceptionally weird. Huh? Yes, the sum for a geometric series, and explain why it was so weird, because you're trying to add up a bunch of things that are multiplied, so they're not going to work well together. So let's just remember what we know so far. So we have, these are the ones for, what is this formula for? Jeff? It's not a formula for a damn thing. Arithmetic, so a sequence based on what operation? Addition, arithmetic, addition. All right, and let me put its sum formula down. Remember, this is the one connected to an urban legend. Nothing to do with people dying or anything, so sorry. It wouldn't make a good movie. Let's try an example of this kind, and then we'll talk about geometric. So find A15. What's another way to say this in English? Not just A15. Find the 15th term in the sequence. And this, of course, is find the sum of the first 15 terms. I like it. So this is just the 15th term. That is the sum all the way through the 15th term. So please, dear God, I don't even want to imagine that you continued, although obviously you could. I didn't make this too bad, but don't. Just don't. You can kind of do it on scrap paper, kind of check yourself, that's fine. But I desperately need you to use the formulas, right? So how do I find A15? What's D? 6. Right? I add 6, I add 6, I add 6. Cool. And then what's A1?
-5.
Yeah, -5. Cool. So then I've got AN equals A1 plus 6 times n minus 1. So now I want, let me stop there for a second. So sometimes I'll ask you for the nth term. Find the nth term. And people go, what? That's the nth term. Nth term meaning I haven't told you which one I want yet. So it's going to be a formula based on n. Now I'm going to ask you, what's A15? So now you just got to put -5 plus 6 times 15 minus 1. So it's a lot like function notation. It's just substitution now, right? And now you just got to work that out. -5 plus 6 times 14.
So to find the nth, we can just leave it as the formula. Just like
Yeah, so if I said find the nth term, this would be the nth term. And then I say find the 15th term, now you plug a 15 in. So what do you get? So yeah, cool. So S15 is going to be a decent amount bigger than 79. Is that cool? I mean, you start with a negative number, so it's going to take away, but then you're adding a bunch of stuff and you get up to 79. So if you get an answer like 20, it should be immediately obvious you're wrong. That term is 79. The one before it was 73 because I keep adding 6. That's 140 already. So I should be up 200, 300, somewhere around there, right? So S15, we'll have to know for S15. I have to know A1. Okay, we know A1. I have to know AN. The biggest mistake I see is this. Let me show you. This is the mistake. Somebody say S15 is 15 divided by 2. So far, so good. N divided by 2 times A1, negative 5, plus AN, and they'll just put 15. Why is that wrong? Why is that wrong? AN. What's N in this case? What's N? 15. So what's AN? A15. What's A15? That's what we just figured out. And that's why I always ask you this question before I ask you that question, because you need this. So that should not be a 15. That should be a 79. That is A15. Please understand. So it would be negative 5 and 79, 1 and 73, 7 and 67. They all add up to be 74. That's the repeated sum. That's the idea that little Gauss supposedly used. Right. Hold a seance and contact his dead teacher and say, what happened? Who are you? And then here you get 15 halves times 74. Whatever the shit that is. 37 times 15. 600 minus 45. I think it's 555. Is it really? Neat. All right. I wish I could claim credit for figuring that ahead of time. Obviously I didn't. I just did it. 555. Now, there's always a disconnect for students. We developed these formulas. We saw where they came from, but then people forget and they just start doing weird shit. Don't forget the ideas of where these came from. I mean, it is just a plug and chug. It really is just plug and chug now that we did all the work of figuring out the pattern. Okay, maybe. So what about geometric formulas? What do they look like? What's AN for geometric? It's based on multiplication, so it's got to be multiplication in here. So you start at A1, and then you just keep multiplying by, what letter do we use? R. R stands for common ratio. The S one is the freaky ass one. I'm not going to go through the derivation again. Here's the formula. You guys actually saw where it came from if you were in the last class. You saw where it came from. You're like, I can never unsee that. It was horrible. But so you can't just look at that and go, yeah, that's what I would expect. No, it's not. It's just something we kind of worked on and out it came. You can't really see anything that immediately jumps out at you like, yeah, that's what I expect. Yeah. So let's try a problem with this. Let me see here. Let me see if I can get you guys to do this. Well, maybe we should do this together. I want to show you where you got to be a little careful. So let's say I have this sequence here. Let's see, what do you got, Jeff? I don't know, Jeff. Gathered extra 0. So this very quickly should be obvious that it's not these. It's not arithmetic. Because I don't keep adding the same thing. My God. Here I'm subtracting, here I'm adding much, and then here I'm subtracting a whole hell of a lot. No. So what do I keep multiplying by?
-5.
Yeah. So R is -5. A1 is 2. That's crazy. So now I can figure out, so here, you guys, see if you can do this. Figure out what A11 is. And I'm going to say this again. I'm still going to get... You will not get points if you just continue the sequence, and that's all you do. God, it's creepy, man. Yeah, I watch too many horror movies. Make sure you use the right formula. Hopefully you understand it's going to be kind of big. Geometric grows much quicker than arithmetic could ever hope to. So see, A11 would equal A1, 2, times R, negative 5, to the n minus 1, 11 minus 1, 10. I like it. Negative 5 to the 10th power is going to be, and then when you multiply by 2, I like some of you guys are looking at your calculator like, what are you trying to tell me? So let me see. Let me get there with you guys. Yeah.
How did you get n? What is
In the question.
Oh,
The question is A11, so n is 11.
okay.
Yeah, so it's based on which term they want me to find or how many terms they want me to add. Okay. So this is 2 times 5 to the 10th. Oh, okay, it's not that bad. I thought it was going to be freaky. What are you guys kidding? Is it freaky? It doesn't look freaky.
95 trillion something?
Don't you get 195? Right. Yeah, 1953. Where'd it go? 1250. Yeah, 19,531,000. Is that what you guys? Do you guys get that?
Yeah.
Please, nobody be telling me it's negative 10 to the 10th. Right. That goes directly against. Please excuse my dumbass son. Right. You got to do negative 5 to the 10th and then double it. Yeah. So if you just plug in the calculator like this, it will understand. So that's the 11th term. Will the sum of the first 11 terms be about as big as that, or what do you think? It's going to be an interesting question to ask. It's a little bit weird. But what's weird about this sequence? If you go to add up these numbers, what's kind of happening as you add them up? Yeah, they keep, that's a 2, and then it's a negative 8, and then it's a 42, and then it's a negative 208, and then it keeps positive, negative, positive, negative. It keeps kind of like canceling chunks of itself out. So let's see, what will S11 be? So take a minute and figure out what S11 is. Is going to be, oh, I see what I did. 5 is 6, 5 is 3, 17 million, right?
16 million.
So yeah, so let's plug this stuff in. 2 times 1 minus negative 5 to the nth 11 over 1 minus negative 5. Gross. Already the room is saying, nobody's here. So I mean, you just get 2 times 1 plus some big ass number. I mean, you can put the whole thing in your calculator at once. If you put these parentheses in, if you put parentheses like this in, or just maybe figure out what number this is first. Right? You can put the whole thing in your calculator all at once. So what do you guys get? 16?
276,000.
2?
76.
276?
Then 42.
Oh, 42?
Yeah.
So other people got it. If you're playing along. Anybody else playing along? Yes. One person, okay. Anybody want me to show you how to put that in the calculator correctly? I don't know. Is everybody able to get to that number from this problem? Okay. All right. Can somebody tell me, would A 5031 be positive or negative?
Negative.
A1 is positive, A2 is negative, A3 is positive, A4 is negative. So every even one is negative, every odd one is positive. That would be positive, not a big deal. All right, just want to show you a different level kind of question. Okay. All right. This is what you call, remarkably enough, we call this an alternating sequence. Because we're really creative. Okay. So these four formulas I'm going to give to you. I'm not going to make you memorize them. If you already have memorized them, hey, you're awesome. I love you. If you haven't, it's okay. You're okay with me. I'll put them on the test. Okay. Let me see. There's something else. Nah, I guess there was something from a while back too, but there was something I thought more recently, but no. One thing from a while back that I think I said and then I just kind of missed it in the book is called the change of base formula for logarithms. Let me show you that real quick, and then I'll give you guys the practice test. So if I had log base A of B, let's do this. Log base B of C there. Just because I want the base to be a B. Just it doesn't matter, right? What is that? What's log base B of C? I like perfect response. This is a good response. Go like this. That's beautiful. What does that response mean? I don't have a freaking clue, right? So when I don't know, I call it. What do you call it when you don't know? Algebra. X. All right. Can you rewrite that for me? Okay, so just reminders. We started with this here, right? What I'm going to try to do. What sucks about this if B is 7 or B is 1.28? What are the only log buttons you have on your calculator? Log base 10 and the what was the other one you have? Natural log, ln, right? Those are the only two log buttons you have. So if B is not E or 10, I'm basically screwed. So there's got to be a way to kind of, my calculator should be better than this, but there's a way we can modify this so I can actually have it figured out. Rewrite this. How do you rewrite this? B to the x equals C. Now solve this for x. Because isn't x what we want to know? If I solve for x, it'll actually be in a different format. How do you solve this equation for x? What do you have to do? Yeah, we're going to take what kind of log? Either log, base 10, or ln. Doesn't matter which way, so I'm going to do both. So I can do log b to the x equals log c, or I can do ln b to the x, chef guy, equals ln c, right? I don't know why you became huge. Yeah. Doesn't matter. And then, of course, the x can come down, And then I can divide by log b. So I get log c over, you just want to be huge, okay, fine. Log c over log b, or the same way x equals ln c over ln b. Now here's the kick-ass part about this formula. Whatever number is in the base ends up in the bottom, right? So the base is the bottom and the inside is the top. I mean, the other thing is the top. It's remarkably simple to remember. So let's do an example. So let's say I had this, I said, use your calculator to tell me what log base 17 of 4,931. Use your calculator to do that. You like? So what's going to go on the bottom? Log 17. Base on the bottom, other thing on the top. You're gonna love that shit. Now, take a minute. Tell me what that is. Figure that out. Put it in your calculator. Be really careful. It's sort of like Microsoft Word. If you have the old one, I don't know what the new ones do. It does that parenthesis for you. So make sure you close it before you continue, or else everything's going to be in the first log. Just take a look what it does, Jeff. Yeah, okay.
3.0.
It still does that in the new one. It still puts a little parenthesis. I see you're trying to write a log. Let me put a parenthesis. Screw you. You guys share my frustration? Microsoft Word. I'm going to try to guess what you're doing. Get out of here. Stop that shit. You do what I'm trying to do. I'm sorry, what do you guys get?
3.0.
3.0?
Yeah.
3.0?
Oh, 1, 2.
Okay, 0012. All right. I almost got a perfect one. What is 17 to the third power?
4913.
4913? Oh, man. I felt you just lost the game on Price is Right or something. I got close. You guys have no idea what I'm talking about. Just, does that make sense? Now watch. What's the other way I could have done this? I could have done natural log of 4931 over natural log of 17. Just take a minute and do that in your calculator. It feels like it should be different. Logs are weird things. You get the same number, right? Hopefully?
Yeah.
Yes?
Nice.
What do you mean, kinda?
It's just straight 3.
Really? Anybody else get that? Or did you swap? Oh, you swapped them around. You swapped them. Yeah, you did. Yeah. It's got to be the exact same number. Anybody else playing along get the exact same number?
Yeah.
It's just a property of logarithms or ratios. Don't care which log you use. Kind of freaky. Yes.
Can you write the base on calculator?
That's what this exists for, this change of base formula. See, that's why we call it the change of base. The base on this problem was 17. What did we change it to? 10, or we changed it to base E, right? Why would we do that weirdness? Because that's already my calculator. I like it.
We do have log base.
I know. I don't care. You gotta keep that stuff to yourself, man. Other people find that on their own. But let me see. A little review here and show you where this kind of pops up. If you were to solve 23 to the x equals 49 or something, you could do log, the natural log of both sides, right? You could do log. How do you rewrite this as a log in a log form? How would you rewrite this? It'd be log base.
10.
No.
X log 3.
No. Rewrite this in logarithmic form. So log base 23 of 49 is x, right? Because the log is a power. Bam.
How is that solved?
All right, so this is something we all have to be able to do. We all have to be able to start in a logarithmic form and go here, or start in exponential form and go to log, right? That's all, yeah. So the output is the input, and the input is now the output, because they're inverse functions, right? But what did we learn now? Wouldn't we have done ln, the x would have come down, and it would have been ln 49 over ln 23? But isn't that exactly what the change of base formula says this as now? ln base on the bottom of the number on the top. That's exactly what I would have gotten if I would have done that the way that we first looked at. All right, okay, all right. Now to me, the less buttons you know exist, the better off you are. Because buttons always hide what they're doing. You got to understand stuff to make connections later. And I think that's getting less and less given to you. You have less shit that you build stuff on. It's harder for you to make connections later. It's not entirely your fault. You're just not teaching math correctly anymore. It just makes me a little sad for the future. I don't know. I'll come off of that. So let me see. I think that was it for catching up on stuff. So any leftover questions I didn't address about stuff or anything left over before we do this, work on this practice test together or alone? Okay.